All right, we're going to look at another example here dealing with summations. And this time I actually have a limit in front of the summation. And one of the things that I hope you start getting used to is the idea of when you see certain pieces, you should automatically realize I'm dealing with X. Okay, I'm dealing with this particular type of scenario. In this instance, I see the summation in a limit, which means I'm probably dealing with an integration, which means that this is a sum, this is a total, this is an area under a curve of some sort. And the question might be, well, what particular expression or function or whatever is this attached to? Well, there are a couple of key indicators here, okay, and let's talk about those for a second. First and foremost, right here, okay, that would be your width. Okay, that'd be the change in the x between the individual pieces. So whatever your curve is, let's just make some generic curve over here. I have no idea what this shape really is supposed to be like because I don't know what the function is. But let's just say that's the generic curve. And we're going from point A to point B, okay, from there to there. The width for our rectangles, that piece right there, that width right there is W. And that's found by doing B minus A divided by the number of pieces. Well, in this instance right here, we're letting n go to infinity, so n is a constant, but here n is a variable. So we actually have a nested situation where we're treating something like a variable in one spot and as a constant in the other. Inside the summation here, n is a constant. Inside the limit, n is a variable. So just make sure you're clear about that. K is our variable inside the summation. That's the piece that's changing. All right, so we have the width down. Well, if the width is 1 over n, it's actually giving us a pretty good indication. So this is what we're dealing with, 1 over n. That's what that is equal to. Well, that's a pretty good indication of what the value of b minus a is, right? Both the denominators are the same, so b minus a is equal to 1. Well, how does that happen? Well, that happens when they're just 1 unit apart. So we're going from 3 to 2, right? So 3 minus 2 over n would give us 1 over n. 1 minus 0 over n would give us 1 over n, right? What it means is the interval that we're dealing with is just 1 unit. So which one is it, right? So there's actually a lot of ways we could probably set this up, but I'm actually going to make the statement that it can't be that one. And this is why I'm saying it can't be 3 minus 2. And this is why I'm saying the interval can't be from 2 to 3. These little brackets here mean inclusively, including 3 to 2. I'm saying it would have to be 0 to 1. Now, why would it have to be 0 to 1? Look at the second piece here, all right? And this is the part where you have to go back and you have to remember when we're dealing with Riemann sums, right? And you're like, it's the first time you're saying this in the video, right? Riemann sums. What was a Riemann sum? A Riemann sum was a way for us to approximate the area under a curve from A to B, right? If we let the number of intervals the number of subintervals in that region from A to B go to infinity, we then now are talking about this being the integration from A to B of whatever that function is. Notice there's an equal sign there. It's exactly equal to each other, right? So what we're dealing with here is a Riemann sum. Okay, you're like, how was I supposed to know that? By the process I just kind of mentioned here. I identified W as being 1 over n, and then I see that I have this part right here where I'm having something to a power and I have k over n. So that's a pretty good indicator, because think about what this means here. Think about your formulas for Riemann sums. You have the summation from k equal 1 to n of b minus a over n, which was your w, times f of a plus b minus a over n times k. And the other version of this was the summation from k equal 1 to n of b minus a over n times the function evaluated from a plus b minus a over n and k minus 1. This was your right-hand Riemann sum. This was your left-hand Riemann sum. Okay? Now, if you look at this, what we're dealing with up here is a right-hand Riemann sum. There's k. We've already established the fact that our width is b minus a over n is 1 over n, right? So this piece right here is 1 over n times k. And then you say, well, what about a? Well, the only way that can work is if I have 0 plus that. So there's the start of my interval at 0. The width of my interval is 1, which means it goes from 0 to 1. And then I'm dealing with k, which means that my function here is actually already stated for me. We're saying that f of x here is equal to x to the 5th, because I'm taking that stuff, which in this particular instance, all right, was 0 plus 1 over n k. I'm doing f of all that. Well, if that stuff right there simplifies into f of k over n, and that's equal to k over n to the 5th power, the only explanation is that f of x is x to the 5th. So there we go. Now we figured out that the function is x to the 5th, and it's being evaluated from 0 to 1. That's the interval that we are looking at. Okay? And you might be asking, well, when would we want to use this? Why would we care? Part of the things that we're going through in this particular course, and this is true across the board in mathematics, is that sometimes we learn things kind of the same way why you do push-ups when you play when you're a football player, or why you go running when you're a soccer player, or why you I don't know. I don't have any experience with some of these sports. So like, for instance, if you're playing lacrosse, I would assume you do arm workouts and shoulder workouts because you want stronger arms and shoulders because you're going to be doing a lot of throwing. I knew a professional baseball player once, and he did all sorts of interesting exercises just with his forearms because he was a pitcher and he wanted to make his hands stronger. Sometimes we do certain activities because they strengthen our skills in such a way that allow us to be able to do other things more efficiently. This is one of those situations where this example, as we ran through it, helps you understand the idea of Riemann sums a little bit more efficiently. And that's the purpose behind this. Am I on a test going to ask you to identify this? I might. That's not really the point of what I'm getting after here. The point I'm getting after is I want you to be able to understand what a Riemann sum is and be able to go back and forth with this, because that means you understand it better. Okay, so be working on that and thinking about that and asking questions as needed. Take care.